potential energy of a particle in a force field is U equals A by R square minus B by R. A, B are positive constants. R is the distance of the particle from the center of the field. For stable equilibrium, the distance of the particle is. So we have, this is the potential energy, which is A by R square minus B by R. Now force is equal to minus du by dr. Since it is stable equilibrium, so equilibrium itself means that the force is going to be 0. The net force is going to be 0. So therefore this should be equal to 0. That's the first thing. And it is stable equilibrium. So as we can see it in the graph, that this is unstable and this is stable. So in stable equilibrium, you see here, if you can see, the slope is going to be 0, which is like seen here, that du by dr is 0. This side, the left side, we have du by dr to be negative, the slope is negative, and here it's du by dr, the slope is positive. Okay, so now since the slope is changing from negative to 0 to positive, so therefore we can write that slope of the slope, that is, this is equal to positive. That means d2u by dr square is positive. That's the second thing. Now let us do this. So we have like, first of all we want to find out the force where it is 0, so we differentiate it. So du by dr becomes a, okay, minus 2 r to the power minus 2 minus 1 minus b minus 1 r to the power minus 1 minus 1, which is equal to minus 2a by r cube plus b by r square. Now this should be equal to 0. Okay, so here how we have done the differentiation is done by using this formula. d by dx of x to the power n is equal to n into x to the power n minus 1. So in the first case n is equal to minus 2, sorry, and in the second case n is equal to minus 1. So therefore minus 2 and this much minus 1. Okay. So therefore this becomes divided by r cube minus 2a plus br. Now this has to be equal to 0. So therefore r is going to be 2a divided by b, by putting the numerator equal to 0. Okay, now we differentiate and we find out the d2u by dr square. So d2u by dr square is going to be, so we have to differentiate this now. So it's minus 2a, okay, into minus 3 r to the power minus 3 minus 1 plus b minus 2 r to the power minus 2 minus 1, which is equal to 6a divided by r to the power 4 minus 2b divided by r cube. Okay, so therefore we have d2u by dr square is equal to 6a by r to the power 4 minus 2b by r cube, which is equal to again 1 by r cube Now 6a by r minus 2b. Now at r was 2a by b, at equilibrium r was 2a by b, so therefore it's going to be 1 by r cube 6a divided by 2a by b minus 2b. A is gone, this is 3b minus 2b, so this is b by r cube. Now since r is, this is positive only, okay, so therefore, and b is positive, it's mentioned because a and b are positive constants, so therefore if you see, this is coming to be greater than 0. So since it is coming greater than 0, so therefore it's stable equilibrium, so therefore the answer is going to be 2a by b. Now one side note here is, actually this d2u by dr square, it's not required to calculate. Why? Okay, see, this is the theory, that's okay, but since we are getting only one equilibrium point, which is r equals to a by b, there are no other equilibrium points, okay, and that matches with the option, so therefore we'll just tick b and we will move ahead. However, for the complete understanding, I have we have solved the entire question. Thank you.